think I'd rather go straight to equations. We need you to be able to solve most any equation come up against. So let me start writing some, and we'll talk about solving them. Okay. Last time we were doing just simple linear equations. Let's try something like this. Here we have variables on both sides of the equation. So what do you think the next step is?
To do the parentheses.
Okay, good, good. Get rid of parentheses. How do I do that? What's the next line?
So it would be 3x plus 15.
Equals?
Equals negative 2x plus 7.
Okay. And now you have equations and, or excuse me, have variables and numbers on both sides of the equal sign. So what do you want to do next?
You have to move.
You want to gather like terms, right?
Yeah.
Okay, and you have to decide which side you're going to put your x's on and which side you're going to put your numbers on.
Okay.
So where are we going to put our x's? Let's decide that first.
We put our x's on the right or the left side?
The left side, and I'll get to a reason in a minute. So what do we have to do to get all the x's on the left side?
You have to subtract 3 to both sides.
You always do the opposite. Right now that 2x is being subtracted because of the negative sign in front of it. So we're going to add 2x to both sides. So I'll do this in 2 steps. We'll just get rid of the x first. Still leaves 7 over there. And now what?
Oh, and then you add, or you subtract 15 from both sides.
Okay, so the next line is? What's 7 minus 15? Tamlin, you still there, or did I lose you? You can go ahead and make sure you have a calculator around when we do sessions.
Okay.
But I would prefer you try to do it in your head first. So what I'm going to do is I'm going to subtract 15 from that side, and then I'm going to subtract 15 from that side. So what is 7 minus 15?
It's negative 8.
Yeah. And the last step?
And then you divide by 5.
Okay. What's the line?
X equals
Okay, so here's what you're doing. And then those two 5s cancel out. So you're left with x equals that.
1.6.
Leave it as a fraction. One should always leave it as a fraction. Okay? Just, there's reasons for that, but for the work we're going to be doing, you're better off leaving it as a fraction. Now, it's important to understand one thing. That is the same as that, which is the same as that. Okay, you understand that? Doesn't matter whether the negative sign's in the numerator, the denominator, or out front. That's all three of those are the same value.
Okay.
Okay. All right. Let's talk about fractions. Okay. Again, we have x's and numbers on each side of the equation. So what's our first step going to be?
Combine like terms.
Okay. Now, which side do you want the x on in this problem?
The right side.
Yeah, because probably the key thing in determining that is what is going to leave you with a positive coefficient.
Okay.
Okay? Now, I got a couple of choices. I can do it the way you just described, but I'm still going to have all these fractions. So, can I make this problem easier by multiplying both sides of the equation by some number? And if so, what would that number be?
1.
How about the least common denominator that we're looking at?
Oh, 2.
8.
8.
8, in other words, for something to be a common denominator, all the other denominators have to divide into it evenly. So it
Okay.
can't be 2 because 8 does not divide into 2. Can't be 4 because 8 does not divide into 4. But it can be 8. 2 divides into 8, and 4 divides into 8. So I'm going to multiply the left side by 8 and the right side by 8. Now, what is this? 8 times, in other words, distribute.
So it's 8 over. Would you keep the?
Always
you...
cancel first. Cancel that 8 with that bottom 8, and you have 1.
Okay.
So that's just x. Now, what is this times that? And I want you to do the same thing. I want you to cancel the 8 and the 2 before you multiply. In other words, don't make that 24 divided by 2. Make it 4 times 3. Do you see the difference?
Yeah.
In other words, this 8 and that 2 are going to become a 4 times 3, so I have 12.
Okay.
Now let's do the same thing on the right side. Reduce the 8 over 4. So what is this times this?
24.
No, reduce. I want you to divide top and bottom by 4. To reduce that, what is 8 over 4 equal to?
2.
Yeah, do that first and then multiply 2 times 3, so you'll get
6.
x. And notice I did not have to deal with a number bigger than 8.
Yeah.
Whereas the way you did it, you would have had to deal with 24 over 4, which is 6, but it's just always faster to reduce.
Okay.
And then finally, this times that.
Oh, it's 8.
Minus 8.
Minus 8.
Now notice what we've done. We've taken a problem that had all these fractions in it, and with one step, I've turned it into a problem that has no fractions. So, and this is the same equation as what I started with all those fractions. I didn't change it, I just multiplied both sides by 8. So now we can simplify it a lot easier. Which side of my x is going to go on?
The right side.
How many of them are there going to be?
7x.
Okay, how do you get rid of the x on the left? If I'm going to move everything to the right, I got to get rid of the x on the left. What is it currently doing?
Adding.
So what do I got to do?
Subtract.
So what's 6x minus 1x?
5x.
Okay, and this time at the same time, rather than in a separate step, I'm going to move my numbers to the left. So what do I have to do there?
So you have to add 8 to 12.
Which is?
20.
Okay. And finally,
Divide by 5.
which is?
4.
There you go. That's the answer. Now, when you're dealing with equations, it really does not matter which side x is on. Just as valid to have it on the right side as the left.
Okay.
Okay. Let me find some others here. Here's a good one. Solving equations is just absolutely mandatory in algebra. Everything comes down to solving equations. It really does. Word problems, geometry problems, all of them end up giving you equations that have to be solved. Okay. So, first step.
Solve in the parentheses first.
Yeah, I call it getting rid of the parentheses. So starting from the left, get rid of those parentheses. What should I write?
So it's just negative x minus 1.
Okay, this negative sign has to be applied to that term, and it also has to be applied to that term.
Okay.
So the second term is plus 1.
Okay.
Because a negative applied to a negative, meaning multiplied, becomes a positive.
Yeah.
Okay, good. Same thing on the right.
3x.
Hold on. You're multiplying.
Negative.
Yeah, you're multiplying that by each term. In other words, that is a negative sign there. That is not a subtraction.
Okay.
Okay, so it's minus 3x. And now that times that.
Plus 9.
Okay.
Yeah, it's plus 6.
I'm sorry?
Oh, no, plus 9. Sorry.
Yeah, it is being multiplied, so it's plus 9. Okay, now which side are we going to put the x's on? And
The right side.
the thing you should look for is which side is going to give us a positive coefficient. Can you figure that out? In other words,
Right.
move the negative 3x to the left, I'm going to have a positive 2x. If I move the negative x to the right, I'm going to have a negative 2x.
So move it to the
I'm going to recommend we move the x's to the left, giving us this. We can combine that 1 and 10 to make 11. So let's get rid of the 11 by how do we get rid of the 11?
We subtract 9.
No, we're moving the 11 to the right. So we're getting rid of the 11. So I got to subtract 11 from 9.
Oh, okay.
What's 9 minus 11? 9 minus 11. A bigger number from a smaller number. Just subtract the two numbers.
Yeah.
And it has to be plus or minus.
Minus.
Yeah, whenever you have a bigger number from a smaller number, if there are no other negative signs, in other words, that is a straight subtraction problem. There's no real need to turn that into an addition problem. Just go ahead and do it as a subtraction. 11 minus 9 is 2, but I've got a bigger number from a smaller number, so it has to be negative 2. Finally,
Okay.
final answer.
X equals 1.
Negative 1.
Negative 1.
Because I've got a negative 2 being divided by a positive 2. So, okay.
Okay.
Let's go on. So far, we have only dealt with equations with one variable. Okay?
Okay.
And let's go up one level. Let's just introduce exponents. How do I get rid of the exponent 2?
You distribute.
No. I'm trying to get to x equals something. So the only thing I got to get rid of is that. How do you get rid of something that's being squared? What's the opposite of being squared?
Divide.
No. Division is the opposite of multiplication. The opposite of something being squared is to take the square root.
Oh, okay.
Okay, in other words, I'm going to take the square root of both sides. Well, the square root of something being squared is that something. So I definitely get my x over there. And this is one time where, because I'm solving an equation, the square root of 25 is actually plus or minus 5. What I tell all my students is that whenever you're solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus, because it's the thing they forget the most, is that plus or minus. How do I solve that? Remember, we're headed for this. So what do I got to do? I got to get rid of everything that's with it.
Yeah.
Which one do I want to get rid of first? The negative 1 or the squared?
The squared.
No, actually the negative 1. And the reason being is that if I take the square root of that, there is no square root of that. Okay. Whereas if I get rid of the 1 first, now I can take the square root of what's left. So what's the next line I want to write?
X squared. No.
Yeah.
Yeah.
Yeah, we're getting rid of the minus 1. So
Okay.
How am I getting rid of
it? The square root of it?
Well, first of all, I got to get it to the other side. I need the line that I'm trying to write. So x squared equals what?
Negative 1.
No. What did you have to do to get rid of the negative 1? You had to add. You always do the opposite. If something is being subtracted, then you add.
Okay.
And so I had to add 1 over there.
Okay. So it's just positive.
That. Correct. Now, what do you do next?
Then you get rid of the 2.
Okay, how do I do that?
You find the square root of 1.
Okay, what's the square root of 1? What two numbers, when multiplied together, equal 1?
1.5, no.
1. 1.
5?
1 is the answer. 1
Oh,
times 1 is 1, right?
yeah.
1 cubed, 1 times 1 times 1 is also 1. So 1 is a number that it doesn't matter if it has an exponent on it, it's always 1.
Okay.
However, because I solved this by taking the square root of both sides, what words do I have to begin my answer with?
Plus or minus?
There's your answer. Now, if you think about it, is minus 1 a solution? Well, sure. Minus 1, if I square it, that's equal to 1. So that minus 1 works. Minus 1 is definitely one of the roots of 1. Okay, so it's not just 1, it's minus 1 also.
Okay.
Now, how much factoring have you had? Do you know how to factor greatest common factor?
Yes.
Good. We got a lot of work to do. Before we get there, I want to talk about equations with two variables. Now, when you have equations with only one variable, you can always figure out the answer to x. But when you have only one equation and you have two variables, you can't solve it for both variables. The only thing you can do is solve it for one variable in terms of the other. So let's say I want my final answer to be in the form of y equals something. Okay?
Okay.
So how am I going to turn this thing up here that's in standard format into slope-intercept format down here? So what can I do for starters?
You can plug the 10 in for y.
No? Because all we're doing is the same exact thing we've been doing, is we're going to rearrange stuff. Okay?
Okay.
Move some things on the left side of the equation, some things on the right side of the equation. So notice that if I move the negative y to the right side of the equation, it'll become positive y, right?
Yes.
So I'll end up with this. Follow me?
Yes.
Now, if I'm trying to solve for y, the only thing I have to get rid of is the 10. So it would be 5x minus 10 equals y. And that is my answer. I just got the y on the wrong side. I switch them really easily by just doing that. In other words, when you have an equation, whatever's on the left and whatever's on the right, they can always be switched.
Okay.
Okay? And notice that this is in slope-intercept form. Y equal mx plus b. Familiar with that?
Yeah.
Okay. Meaning this is also the equation of a straight line. When you have one y and one x, and they're both to the 1 power, you have an equation of a straight line. If I wanted to graph that line, where would I start?
You'd start at negative 10.
Good. And then you'd apply the slope how? What's the slope?
So it'd be 5 over 1. So you'd go up 5 and over 1.
Which way over? To the right? Where's up 5? I want to go to the right or the left?
The right.
Yeah, because I want to make sure that I have a positive slope. I know my slope is positive 5. And had I gone up 5 and over to the left one, I would have a negative slope, right?
Yeah.
Let's talk about slopes. I'm going to draw a bunch of slopes, and I want you to tell me whether they're positive, negative, or neither. What's that one?
Negative.
It's positive.
Oh, yeah, because, yeah, positive.
Because I'm going up, and I'm going over to the right. So that is positive. And I tell you how I figure it out. Is I go to the lower left part, no matter what it is, and I put a ball on it. That ball got to go uphill or downhill to go to the right? It's got to go up.
It's going to the right?
Yeah, in other words, if
Yeah.
I'm going to push that ball in this direction, it's got to go uphill. Uphill corresponds to a positive slope. What if I have a line like this? What is that?
Negative.
Yeah, if I put the ball on the top left like that, it's going to roll downhill. You won't have to push it. If it rolls downhill, it's negative slope. If you have to push it uphill, it's positive. Okay?
Okay.
Yeah, I'm not quite done with that. Let me, about that slope, horizontal line.
It's undefined.
No, it's actually 0.
Oh.
The one that is undefined is a vertical line. That's undefined. But a horizontal line has a slope of 0. And let's talk about why. Approximately, what is that slope?
Positive.
It's 1.
Oh.
Right? In other words, that's about a 45-degree angle. That looks like it goes up 1 and over 1. I was trying to draw a slope of 1.
Okay.
Okay? Now, a slope of 2 is like that. Whereas a slope of 1/2 is flatter. You with me?
Yes.
So if a slope is steeper than 1, it's a positive steepness. And if I go all the way down here, I get a slope of 1/4. And you can see that by the time we get to horizontal, my slope is 0.
Yeah.
Now let's go the other way. That slope right there is like 10. And if I get even steeper, that's like 100. And 1,000 slope, that would be like 1,000. So what are we headed for here? By the time we reach a vertical line, what number are we approaching? Infinity.
Or infinity.
Yeah, in other words, it actually does approach infinity. And that's why they say it's undefined, because infinity is not a number. So you don't say the slope is infinity. You say that it's undefined. But that's
Okay.
what slopes do. In other words, the steeper they are, the bigger number they are. Now,
Okay.
what if I have a slope like this? Positive or negative?
Negative.
Okay. Is it negative 100 or is it negative 1/10? If I said it's one or the other.
Negative 100.
Yeah, it's a steep slope, so it's got to be a number bigger than 1. A negative 10th slope would look something like that. Very, very close to horizontal.
Okay.
Okay? So that's why they put so much attention in this equation, where m is slope and b is the y-intercept. And anytime you get a linear equation, you want to be able to put it into that form. Let me give you one more. This is a linear equation, meaning straight line. It's got one x, one y in it, and they're being added. They're not multiplied. So it's not quite, in other words, if I give you this, that's not a straight line because they're being multiplied. They have to be being added or subtracted. In other words, you have to be able to get it into y equals mx plus b format. So how do I get this into y equal mx plus b format?
So
Still trying to get to the bottom with y equals something.
would you divide by 4?
Only problem with dividing by 4 is that I got to divide the x by 4, and I got to divide the 4y by 4, and I got to divide the minus 8 by 4. So that creates a little bit of a problem. Not really, it's just more arithmetic. Let's get rid of the x first. It's easy to get rid of the x.
Okay.
So what's my next line going to be?
Equals 8x or negative 8x.
Okay, I'm not multiplying. So I'm not multiplying the x times the 8. I'm merely subtracting an x from each side, right?
Yeah.
It's going to get rid of that x, and I'm going to have a negative x over there, and I'm still subtracting 8 from it.
Okay.
Okay? So make sure you distinguish between multiplication and addition when you're moving stuff around in these equations. And finally, the last step is what?
Get rid of the 4.
Okay, by doing,
The division.
man, I could just erase it. That gets rid of it, but am I allowed to do that?
No.
I get rid of it by dividing both sides by 4. Okay? Or that side by 4, and I divide both terms by 4. So what I'm left with is minus x over 4 minus, what's this?
Negative 4.
What's 8 divided by 4?
2.
Okay. And I already put the minus sign down. So I can do just the 8 over 4 since I've already put the minus sign down.
Okay.
Okay. Now tell me what the slope is.
1 over 4.
It's negative. In other words, let's rewrite this so that it's in precisely that format.
Okay.
And there's a 1 right there, right now. It's just we don't write it.
Yeah.
The better way to write this is like this. That is then precisely y equal mx plus b format. I now know the slope is what?
Negative 1/4 x.
Not x. It's just the coefficient of x. The slope never includes the x as part of it.
Okay.
Notice that the m multiplies the x. So once you figure out what the m is, it's all by itself. No x. And what's b?
2.
Include the negative sign.
Negative 2.
negative 2. And so how do I graph it? I start where?
Negative 2.
And how do I produce a slope of negative 1/4?
You go up 1 and over 4 to the left.
Good. And there's my line. Whoops, meant to go through that dot. And is that a negative slope? Always check. Put a ball on it, it rolls downhill, therefore it's negative. Downhill is negative.
Okay.
Okay. All right. That's a good one. Now, first of all, let me address something. This is the way it was in the book. Right? And that's the way they teach.
Okay.
Do we need those leading zeros?
No.
Do they get in the way?
Yes.
Yeah, I think they get in the way. I don't ever write them. I mean, never. I'm trying to erase it. It's not letting me erase it. Let me erase that. There I go. Notice this is much easier. I'm not looking at a bunch of unnecessary zeros. So whenever I have a decimal that starts with a decimal point and then numbers, I do not ever write that leading zero. It's a waste of time. It's a waste of energy. It doesn't add anything, and it does take away because it just gives you more numbers you're looking at.
Yeah.
Okay. So first step, remember I'm looking for this format, y equal mx plus b. First step.
You wanna do you want to move your x to the other side?
Yep, that's exactly right. Now, before I do that, is there anything I can multiply this equation on the left and the right to get rid of these decimal points?
You can do the 0.5 or
What have
0.5y.
What have I multiplied the entire left side by the number 10? Means I got to do the entire right side by the number 10. And what do I have on the left? What's 10 times 0.1?
1.
What's 10 times 0.5?
5.
What's 10 times 3.5? Anytime.
35.
Okay. Which equation is easier to deal with? The one that had all the decimals or this one?
This one.
Okay. So first step, you can always do that, Deli. We did it with fractions on the other problem, but you can do it with decimals too. In other words, you can do anything you want. The most important thing to understand about algebra, when you're solving equations, is you can truly do anything you want. You can smash it over with a chair, as long as you smash the right side with a chair.
Okay.
Okay? So the second equation is the same as what we started with, but it's much easier to solve. So what's the next line? Just read it line by line.
Then
Yeah, what would you do next? Now that I got x plus 5y equal 35.
you subtract x from both sides.
Okay, so read the next line.
So
You don't
5
actually have to tell me what you're doing. If you can read the next line properly, I'll know you've done it correctly.
5y equals x plus 35.
Almost. What do you have to do to get rid of that?
X minus 35?
It's minus x.
Oh, okay.
In other words, it's a plus x on the left side, but when I move it to the right side, it becomes minus x. I put it in front because I want my x term to be in front.
Okay.
And the final step?
And then you
Put it in the fraction format where you can figure out what m is immediately.
so you divide by 5.
Okay, so give me the answer. Y equals?
Y equals 5x, negative 5x.
Okay, you're dividing by 5. In other words, I'm going to divide that by 5. So now tell me what that is. Put the fraction out in front of the x so that we know exactly what m is.
Y equals
Negative.
Negative.
Remember, there's an imaginary 1 there. Not an imaginary, but there's a 1 there.
5x.
No, it's 1/5.
Oh.
That's the part we're looking for. That's what m is negative 1/5. X plus, what's that? 35 by 5?
It's 7.
Good. That's how you do it. Let's see what else I can find in this good book here. Well, let's do this problem. Now, you might say that this might be a linear equation because you have an x and a y, but it's not, because you have an x and a y that are multiplying also. So to solve this requires a little different. What's the greatest common factor on the left side if I look to factor this?
1.
No, how about x?
Oh.
In other words, and it's the greatest common factor, and I mean that literally, it's the greatest thing that divides evenly into both terms. In other words, it divides evenly into x, and it divides evenly into that. So if I factor the x out, what am I left with? What's that?
X.
You were going to say it. I heard the first vowel come out. What's x divided by x? What's 7 divided by 7?
1.
What's 9 divided by 9?
1.
So any number divided by the same number is 1. In this case, we don't know what the number is. It's x, but x divided by x is always 1.
Okay.
What's this part over here? And I've already put the minus sign because it's a fraction. So I'm only circling the stuff without the sign. What can you do with those x's? Huh?
2y.
Okay. Now, can't really solve this for y. Well, actually I could. Let's talk about that in a second. Let's assume I want to solve this for x, which is always possible. In other words, you're not always solving for y. Sometimes you're solving for the other variable. So how would I do? What would I do now? What is with what is with that x in parentheses?
You would have to get rid of the parentheses.
No, that's going backwards. We came from there. In other words, to get rid of the parentheses, I would multiply it back together again, and I would get back to where I started. I'm trying to not get back to where I started. I'm trying to get rid of this. What is that doing right now?
It's getting in the way.
Multiplying x, is it not?
Yes.
So I want to divide by 1 minus 2y. So if I divide the entire left side by 1 minus 2y, divide the right side by 1 minus 2y, that goes away, and I'm left with just x. And so my final answer is x equals 1 over 1 minus 2y.
Okay.
Okay? So that is when your multiplier is a binomial term, not a mononomial. So far, everything we've dealt with has been mononomial. It's a binomial term, but it's the entire binomial term that's multiplying the x. So I can divide by the entire binomial term. Now,
Okay.
let's see if we can solve this for y. Because sometimes you want to solve for one variable, sometimes you want to solve for another. So if I'm going to solve it for y, what can I get? In other words, this time I want the answer to be this. First step,
Subtract your x on both sides.
okay, what's the next line if I do that? You're correct. Subtract x from both sides. In other words, there's subtracting it from that side. There's subtracting it from that side. That gets rid of it. What's the next line?
Negative 2 or xy 2xy equals 1 minus x.
Yeah. Now this time I'm not so trying to get the x in front. I don't care if it's in back. Because this is not a straight line. This is a curved line. But I still have work to do. What do I got to get rid of if I'm hoping to solve for y?
You want to get rid of the x.
The minus 2x. That whole thing is multiplying the y. Okay? So I'm going to divide by minus 2x, both sides. Those cancel, and I've got y equal 1 minus x all over minus 2x. And that's a good answer. Nothing wrong with that answer.
Okay.
So it was just a question of whether we were trying to solve for x or trying to solve for y.
Okay.
All right. Let me see what else I've got here. Yeah, here's a good one. You familiar with degrees Fahrenheit and degrees Celsius or centigrade?
Kind of.
32 degrees is freezing in Fahrenheit, but it's 0 in centigrade. Whereas 100 is boiling in centigrade, but that's equal to 212 degrees Fahrenheit. So if I gave you a temperature in centigrade, could you convert it to Fahrenheit using this formula? So what if I said C equals 10 degrees? Can you convert that to a Fahrenheit temperature?
No.
Yeah, just plug in 10 for C.
Oh.
That's the purpose of this formula, is to allow you to convert it. So you plug in your Celsius temperature. do the math. What's that? Do it my way, where you do the 10 divided by 5 first.
5.
10 divided by 5. 5 is what?
2.
2 times 9 is
18.
what was easier, doing that or doing 9 times 10, which is 90, divided by 5? Is it easier to do 90 divided by 5, or is it easier to be 2 times 9?
2 times 9.
Okay. Plus 32. So the equivalent temperature of 10 degrees Celsius is 50 degrees Fahrenheit. So if C equals 0, gets rid of that whole first term, and Fahrenheit equals 32, which is what we think of as freezing. And if C equals 100, then Fahrenheit becomes 180 plus 32 to 12. That's boiling. So something that is 100 degrees centigrade is boiling, and the same temperature in Fahrenheit would be 212.
Okay.
Okay. Now, that's the easy way to do it. What if they give you a Fahrenheit temperature and they ask you to convert it to centigrade? Do they call it centigrade or Celsius in your class?
Celsius.
Celsius? Okay, I'll try to remember to use that term. They're the same thing, but
Okay.
Celsius and centigrade. Okay, so in other words, if I'm going to give you a Fahrenheit temperature and to figure out what the Celsius would be, it'd be better if I could solve this equation so that I have C down here on the left all by itself. I don't care if it's on the left. It could be on the right, so I won't put it anywhere yet. But we're going to solve this for C. Now, this is not X and Y, it's F and C, but that's the same concept. It's just two variables. So we're going to do it the same way you've been doing the other.
Okay.
So how am I going to get C all by itself?
You have to.
Do you subtract the 32 first, or do you multiply by 5 first?
You multiply by 5.
Actually, you subtract. If ever you have a number that's just being added or subtracted at the end of a function, always get rid of it first. Because if I multiply by 5, I've got to multiply that 32 by 5 also.
Okay.
In other words, I've got to multiply both sides by 5 if that's my first step. But I'm suggesting we subtract the 32 first, giving us this. Now what?
And then you multiply by 5.
Okay. That'll get rid of that. And now what?
You have to get rid of the parentheses.
Not yet. Let's get rid of everything over on next to C.
You have to get rid of the 9.
Okay, and I do that by dividing. So the final answer, it could be this. I don't have to get rid of the parentheses necessarily in my equation. Because now if I said, okay, what's a 80-degree Fahrenheit convert to? Well, you'd substitute 80 for F, figure out what the 80 minus 32 is, multiply it by 5/9, and that's your Celsius temperature.
Okay.
So I would tend to leave it like that. Notice that if I do distribute it, it gets a little bit more complicated. gets to be minus 160 over 9. So same formula. Personally, I prefer this one on the left. But either one is okay. And either one of them, you have C all by itself, which is what we were trying to solve for.
Okay.
So you're frequently going to have equations that have two variables in them, and you're always solving for the hard one. In other words, it's already solved for F. So solving it for C is the difficult part.
Okay.
See if I can find one more before I leave you that's a little different. Do you know absolute value?
A little bit.
Okay. If I say the absolute value of x equals 10, that actually means two things. It means x is equal to 10, or x is equal to what?
0.
Negative 10.
Oh, negative 10.
In other words, the absolute value always means the positive number. So if I stuck a negative 10 in there, the absolute value of negative 10 is 10, right?
Yes.
I mean, absolute values are really easy in that regard. No matter what goes in the absolute value signs, it's positive.
Okay.
When it comes out. What if I say this? All of these always mean two things, and that's the way you should solve them. And the first thing it means is exactly what I've written without the absolute values. Okay, that's the first thing it means. And then I write it laterally because I'm going to solve them vertically. So what else does it mean? You never change what's inside the absolute value, you just have it equal to what?
Negative 10.
Solve the first equation, what do you get?
9.
How do you get rid of the negative 1?
You add 1.
What's 10 plus 1?
Oh, 11.
Now solve the second one.
Negative 9.
Good. And notice that both of those work. If I plug in 11 for x, I get 11 minus 1. Absolute value of 10 is 10. And if I plug in minus 9, well, minus 9 minus 1 is minus 10. And the absolute value of minus 10 is also 10.
Okay.
So both of these are correct solutions, and you usually do have two solutions when you have absolute value.
Okay.
Okay? But what you do is just always take whatever's inside the absolute value and start there. In other words, rewrite exactly what you've written without the absolute value signs. Or whatever's inside the absolute value signs, no matter how complicated, equals the negative of whatever that number was.
Okay.
That's how you do absolute values. They get a lot more complicated than that, and we'll get into that later. But for now, that's probably a good place to stop.
Okay.
Okay. Tim, we're going to make progress here. So,
yeah.
And the nice part about it is we're going to have a chance to get you caught up completely before you have to tackle some of the harder stuff that you were giving me on the first session that I met with.
Okay.
Okay? So it'll be really good for you. This break in school actually is a great opportunity to get you caught up.
Okay.
Okay, you remember how to get out of this? You just click on the X in the upper right.
Yes.
Talk to you next time.
Okay, thank you.
Welcome. Bye-bye.